Welcome to CancerVac CEO Chats. Today I'm joined by my friend and my colleague, Dr. Satiro de Oliveira. Little background on Satiro. Dr. Oliveira is a board-certified pediatrician and board-certified pediatric hematology oncologist. Satiro received his medical degree in Brazil, and I'm going to try to pronounce this the best I can. Faculdade de Medicina de Ribeirão Preto. How was that?
That's perfect.
Not perfect, but and then he completed his pediatric residency at Woodhull Medical and Mental Health Center in New York, and his pediatric oncology hematology fellowship at Children's Hospital in Los Angeles. Satiro's clinical focus has been pediatric oncology and gene therapies, and his research focus is on cancer immunotherapy and the biology of stem cell transplantation. Satiro has over 30 publications, is named on numerous patents, and has over 10 certifications and received over 13 recognitions. So I've been working with Satiro through a sponsored research agreement that CancerVac has with UCLA, and I've really grown to like and respect him a lot. Very highly intelligent person who's extremely good at what he does. So Satiro, thank you for joining me here on CEO Chats today.
Thank you, Ryan. It's a pleasure to join you here. Thank you for your kind words.
Yeah. So you grew up in Brazil. What part of Brazil are you from?
It is in the São Paulo state, but actually it's a metropolis, Campinas.
Campinas.
A few blocks from Universidade de Campinas, Unicamp.
Yeah. So I once knew an Oliveira, a guy whose last name was de Oliveira, from Campinas.
It's very common last name, yes.
Yeah. Oh, that's great. So I do, knowing that you're from Brazil, I guess you're a soccer or football fan. So I just wanted to ask you, who do you think, Ronaldinho or Neymar? Who's the better player?
Whoa. Ronaldinho in his golden years probably was better, but yeah. Neymar got the longevity.
He does, doesn't he? Yeah. He sure does. I didn't throw Pele in there because that's kind of a dead giveaway, I think. Well, so what is it that initially got you interested in medicine?
So I was actually about to follow my father's career steps. He was a food engineer, and that was a very interesting on learning about his career and the big foot on science, but the applications into society. But as I was applying to college, then medicine came up as the biggest challenge. I didn't have any close relatives who were physicians, so they weren't there to tell me about the bad side of being that. The only thing I knew from medicine was meeting my pediatrician, who was one of the most famous pediatricians in town. So that's why I only had the good examples. So I said, well, let's apply. And at that time, I could actually put first option would be medicine and second option would be food engineering. And I raised up to the challenge and I said, okay, there we go.
So it was a pediatrician rather that kind of was an example for you. Is that kind of, so that took you into the medicine field, but is that sort of what made you lean towards the pediatrician or the pediatric side of things?
Well, maybe not consciously. The main thing that took me to pediatrics was the idea that they are resilient bodies, so they can overcome a lot of different challenges, even if they lose a lot of abilities. And the main thing that attracted me was really the minimum you can make to improve their lives. You earn the whole life of success, instead of actually trying to just pick up the pieces. Someone who didn't treat their bodies well, didn't take very seriously about their health. So probably about the middle of the medicine at school, I was already knowing I would go to pediatrics.
Now, so that's one big revelation is pediatrics is your field. Now, how about hematology and oncology? How did you get interested in that kind of focus?
So the medical school I attended, was very well known for their hematological discoveries. Yeah. And only the best students actually would go into hematology. So that was already the next challenge. And the idea was that it was always on the edge of the science. You take the blood from the patient and take straight to the lab to do studies. And especially as a medical student, I was always enthusiastic to be able to see the cells in the microscope. So that was also the next step and logical choice.
So, knowing that UCLA, it's one of the very top cancer research institutions in the world. Tell me a little bit about your journey from South America, Brazil, to UCLA. I mean, that's a huge deal.
Yeah.
Right. But that's quite a long journey.
Well, I was born in Lafayette, Indiana.
Okay.
With my parents studying at Purdue, doing their postdoc studies.
Oh, super.
So I didn't have any visa issues.
Yeah.
And on top of that, my wife is a PhD in immunology. She's actually way more successful than I am. But it was actually yet again another logical choice to step forward, to come to the US, to move ahead into science careers. Yeah. And in part, it was really because I was feeling a little bit frustrated, even though I was working in Brazil at one of the largest institutions for pediatric hematology oncology. I was just waiting for the next patient, but I couldn't apply everything that was already known. Even up to now, some new drug discoveries in either US and Europe might take up to a decade to reach the market in Brazil. So it was something that I really wanted to be part of, really helping on moving into the new discoveries to make history of medicine. So that's actually why the idea of coming to the US. And as you might know, everybody coming from as a foreign medical graduate, you actually do need to do residency and fellowship. So I actually had to do again residency and fellowship. So I have 2 residencies in pediatrics and 2 fellowships in pediatric hematology oncology. But it was actually good for me because by the time I was in New York doing my pediatric residency, it was already about 5 years I was all focused on pediatric hematology oncology. So it was a good catch up. It was actually a program that we had about half of the residents were already pediatricians in their own home country. So it was a nice experience. I got to Children's Hospital Los Angeles thanks to one of my mentors who already knew the institution I was working in Brazil. So he knew it was a very prestigious institution, and he knew I had much to contribute. So I got to my first option and got to CHLA and joined the laboratory of my mentor, Dr. Donald Cohn, who really pushed me through and brought me to UCLA when he moved his lab. It was just a week I joined his lab, and he said, "Oh yeah, by the way, I'm moving across town to UCLA." But I always tell everyone, this is my dream job. I'm here in a place where we are making science, we are helping patients. It's a nice size medical institution and awesome research community.
Well, it really is impressive, and the fact that you did 2 fellowships and 2 residencies, right? And you said it in such a humble way, but I think that's probably your way of saying I came in overqualified.
Well, I wasted time, but I didn't incur on debt, so it was okay.
Yeah, that's great. So, as an MD, you obviously spend time in the clinic treating patients and working with them as they challenge these diseases, but you spend time in the lab doing research. How much of your time do you spend between the clinic and the lab? And which of those, is there one that you enjoy more, that you're more drawn to? So
as I was kind of building up in my mentored research grant, the commitment has to be 75% for research. So I had a lot of protected time to really make sure I was building my skills and building my own lab and having people working with me. Nowadays, it's more probably around 50-50, not only with my work in the lab, but also working in clinical trials with my mentor and general clinical trials at the whole UCLA community. Some of them, I'm actually the site PI. I enjoy both of them equally because, like I said, this is the challenge and the idea that I'm contributing to science and to improve the outcomes for the patients.
Yeah. Yeah, no, I think it's really valuable. I'm a biotech industry exec, and I've been on this side for a long time. I'm not a physician, so I'm not in the clinic like you are. And I must imagine it's a different experience. I mean, the patient outcomes, the patient needs and disease states and issues and et cetera, I read about those in journals, right? And the fact that you're there on the front lines and then get to jump into the lab and apply that, on the science side, I think it's pretty fantastic. And that's cool. What is Satiro, what is or are some of the most exciting research projects that you're working on? What really gets you amped up?
So gene therapy clinical trials, this is really what my mentor, Dr. Kohn, got me into. And this is so exciting because we are making miracles. We are changing lives. We are making history of medicine. And as I meet these families, I say, listen, 10 years ago, this disease would have killed this child. And now this patient is a miracle. This is really interesting times because we are really not only making it possible, so turning science fiction into reality, but not only helping the patients, but also paving the way to make sure we know how to translate science to patients. It used to be easier. Nowadays, it's way harder, and it requires way more people, way much more money than before, to the point that actually a lot of approaches that are successful in sometimes even approved by the FDA fail into staying available, keeping available to patients. So it's all a part of assistance and keeping the flame alive.
Well, it's interesting that just, in parallel to that, the fact that you're sort of passing things on to this next generation, right, which has been done for you from your mentor. You have an opportunity now to bring students into your lab, and you're now probably, I would imagine, are now mentoring that next generation. Did you ever think that you would be in that position?
Well, it's part of being in academia, but this is actually part of the excitement. It's not just doing my part. It's really making sure we are passing the torch and making sure people don't miss that we are not just doing the bread and butter. We are really building the history of medicine and helping everyone. And like now I'm kind of mid-career. It's interesting how to see that a lot of times the same mistakes happen or the same problems arise, and it's nice to have the confidence to say, oh, take it easy, we'll go through this. There's a better way to go around, and the main thing is really to employ the effort and the creativity to make everything feasible. And I think for both clinical side and research, what makes me really enthusiastic is really the tackling the problem and bringing to a solution. So I try to devote my time where my impact is the most. And sometimes my colleagues and my mentors, they are more valuable in the lab. So I'm the first one to volunteer to go and see patients in clinic. But on the other hand, there's a grant due or the work we have. And those are the days then I'm going to spend the night in the lab and putting the efforts to make things happen.
Yeah. The World Health Organization has a statistic out where they say that cancer is the second leading cause of death globally, right? So we know it's a big deal. It's a big problem. We have a little at Cancer Vax, a little promotional video that we recently done where I talk about just personal history with cancer. My father got cancer at the age of 47. My grandfather passed away from cancer, and it's personal. It affects all of us. So what in your career? I'm sure that's part of what excites you, and I love this mantra that you've just. I'm going to assign it to you because I haven't heard it before now. But creating the history of medicine. I mean, that's a beautiful thing, and I love how you said that. But as you look at cancer, what is the challenge? What are some of the hardest parts? Because clearly there's a huge need. In the research field, we've been looking for cures, for treatments for a long, long time. So what is it about this that excites you? And then also, why is it so difficult, Satiro?
Yeah, thinking about your question, I think there are three ways that I now have come down to why. One of them is the nature of the disease. Cancer is something that arises from the healthy body, made by the same proteins and molecules there are in the healthy body. And not only that, now we know it's most likely arising because there is already some genetic predisposition for that. And it is a result of perhaps some lifestyle choices and day-to-day habits. Yeah. And not only that, thinking about the immunological side, it's probably something that already learned how to avoid the immune system and evade the responses that you already have. So that's already one way to think about why it is so tricky.
That's fascinating.
The second thing is actually, and this I have put a lot of thought recently, is the nature of the drug development paradigm, because it costs so much effort and money to build up and develop a new drug that you want to have the maximum benefit of the return of the whole effort. So a lot of the drugs are developed for the most common cancers and for the diseases that affect the largest number of patients. And that is actually one of the problems we have in pediatric oncology, because by definition, all these diseases are all rare. And if you want to have something that is developed to treat less than 1,000 patients a year, then it is a big challenge. And now we are seeing it's not just a bubble. If companies fail, even if they get to a point where they have a drug approved, essentially because they cannot keep everything moving and treating patients. It's not just making a pill or putting in a bottle. So that is so challenging. The third point is actually something that I've been hearing already, even from the start of my fellowship, that the challenge of integrating all the new discoveries to what you're already using. And pediatric acute lymphoblastic leukemia is an example. We've been so good to help these patients and to increase the survival to up to 85, 90%, or perhaps even more than that, to the point that actually, even if we know now, for example, immunotherapy works, you are not allowed to throw everything you know and you have used through the window and say, let's just do no chemo and use just immunotherapy. So you need to actually match what you're learning. And that was actually one of my initial mentors at my fellowship said, that's the challenge of the physician scientist, is try to bring what people already learned from the lab and try to match to the treatment. And I have no doubt that a lot of new approaches that they could work, we are removing them from the arsenal just because the clinical trials didn't choose the patients who would benefit the most out of them.
That's super interesting. That's really fascinating stuff. Thanks for sharing that. One of the other areas of focus that you have is immunotherapy. How would you describe to the layperson what immunotherapy is?
The simplest way to put is to make use of the immune system, the person's own immune system to fight cancer. Sometimes you could have a way to harness the patient's own immune system to wake up or get stronger and fight the disease that's already there. Sometimes you could borrow the immune system from someone healthy and give to the person who has the disease. That is actually in very raw terms what we do in a bone marrow transplant, for example. And you could do that with borrowing whole cells, like I said, for the bone marrow transplant, or just using, for example, a monoclonal antibody that targets the tumor and then attracts the immune system to come and attack. The most enthusiastic people in immunotherapy for cancer would say that one day we will be able to avoid chemotherapy and just use the immunotherapy. I'm not sure if we're going to get that way, but the idea is really the most exciting is up so far, we've been chasing cancer, treating cancer, mostly using surgery and chemotherapy and to a certain point targeted therapies. So using immunotherapy is a novel modality. So it has created solutions and cures to patients to whom the other modalities failed. So that is actually why it's so interesting. And now we see patients actually having favorable results.
And it's much less invasive, and why not? You know, if we can use our immune system, it really is a beautiful tool. You know, I know that UCLA likely works with a number of outside companies like CancerVax. What are, in your opinion, what are some of the benefits of industry, biotech companies like CancerVax working with research institutions and universities like UCLA?
I think the first point is really the connection with the community and the connection with people who think problems differently, and really to go beyond of just the concern with the academic career that, oh, I need this grant and this paper. What we are doing is going to a bigger goal. It's to really translate what we are doing in science and really move it into a larger scale, to really go beyond what we are doing in the lab and reach the largest number of patients. So for that, we do need not only the help with resources, but also, of course, financial, but more minds. So you need to achieve a critical mass in which you can really expand the scale of your translation. Without that, it's all going to die. And maybe if I don't get the next grant, then I have to shut down the lab. And even if the idea was attractive, nobody will know.
Right.
And in many instances, especially because research funding many times is catering to political interests or foundation limitations. When you go into open source and to biotech, the idea is a business, and you keep moving through, and that's actually what enables passing through a lot of hurdles that you're just repeating experiments that you might use a robot instead of you wasting the time from a trainee or having a building working with you to reproduce and to test all the different compounds you want to test and really accelerate the translation.
Yeah, that's a great answer. And I know from that's a perfect answer from your perspective and from my side. You know, as I start a new biotech company, the cost alone of setting up a new lab is tens of millions of dollars. And, you know, from our standpoint, working with not only universities like UCLA, where they're just brilliant people, but you guys have over many, many years accumulated state-of-the-art labs and technology and equipment, et cetera, where, you know, a small biotech company just can't jump into that without investing, you know, enormous amounts of money. So I think it's a win-win on both ends.
Yes.
Yeah. So in closing, I'd love to hear some advice. If you were to give advice to young aspiring physicians or young aspiring scientists who are maybe a little more prone to be on the research side, what would your advice be?
Everybody talks about following passions when you're talking about careers, but I think it goes beyond that. Of course, you need to love what you're doing, otherwise you're not going to get out of bed. But you also need to put some creative effort to really make it feasible. It's not realistic to want to do research in a particular disease or a patient population if that disease or that patient population is not available in the institution or laboratory you are. So what you need to do is examine what are the strengths in your environment and make the best use of what you have. And that's what I always tell all the trainees. Make sure wherever you go, find what are the strengths in that place, what is the strongest research productivity, who's the most famous person in town, then these are the people you want to work with, because the worst case scenario, you will be known as the person who worked with that famous person. And that will already get you to the next level.
No, that's great advice. Yeah.
Yes, and then that's the idea. Then you keep pursuing. It's hard, and you got to put the effort. But the main thing is to make it feasible, because a lot of people might crash and burn and waste so much energy trying to chase something that it needs extra levels to get there.
Great advice. Thank you. Listen, Satiro, thank you. This concludes our CEO chat, but I just wanted to thank you for your time today. It's been really a pleasure getting to know you a little bit more and talk to you about these things. And we also thank you for all of your efforts and partnership and work on our fun projects as well.
Yes, we'll keep working together very enthusiastically.
Well, have a great rest of your week and weekend. And I think you're going out of town next week, right?
Well, yes.
Enjoy.
Thank you.
Okay, ciao.
Bye. Ciao.